Hello, and welcome to VTOL VR. VTOL VR is a flight simulator that fairly accurately models most weapon systems and technologies, all while keeping them simple to learn and use. There are a lot of simulators that do the same thing. But as the name suggests, VTOL VR is different than the others in that it's been built from the ground up to only and fully support VR. In the case that you've been living under a rock for the past half-decade, a VR headset places two different high-resolution images directly in front of each eye to give depth perception and a high field of view. Headsets usually also come with controllers allowing you to interact with the virtual world. All this can make it very convincing that the virtual world is the real thing. The motion controllers can be used to interact with the virtual cockpit, allowing every switch, dial, and button to be flipped, twisted, and pressed with a simple motion. This gives a very intuitive feel to all the aircraft functions. VTOL VR also uses the motion controllers as a virtual joystick and throttle, allowing us to easily change between different aircraft cockpits and designs. Although there is one issue, the high-resolution images need to be rendered at high refresh rates for each eye of at least 90 Hz, or most people will get VR sickness. This makes the majority of computers feel like the simulator is more of a computer stress test. But before that happens to my computer, let's get started on how aircraft systems work. Welcome to the FA-26B. It's modeled after the F-15 and uses a fairly old design and is great for when stealth isn't an option and we need to carry a heavy loadout. As mentioned, most systems have been simplified. Starting up an aircraft is as simple as turning on the batteries, then the APU, and last the engine. This is generally the same for all aircraft in VTOL VR. Once we started up the aircraft, we can request a takeoff. Tower, Alpha 1 requesting takeoff. On land, this gives us a path to the main runway. And we can take off. On a carrier, we get a catapult we hook up to.
You're cleared to taxi to Cat 4. Alpha 1-1.
And get launched off. Once we're in the air, on long missions we sometimes need to refuel. For this we can either land at a nearby airport or we can head to an air refueling tanker. Air refueling takes a ton of practice to keep the aircraft in a small zone underneath the tanker, but it's probably one of the easiest things in VTOL VR.
Disconnecting. Try to stay within the margins. Contact. What's on it off? Disconnecting. Try to stay within the margins. Refuel complete. You're good to go.
After completing the mission, we can request a landing and get a bearing to follow that brings us to the requested airport.
Tower, copy. Fly heading 132. Expect runway 10.
For landing at an airstrip, we keep the airspeed at around 200 knots and, well, land normally. Aircraft carriers, on the other hand, are at a whole nother level. We must keep the airspeed at 170 knots with an angle of attack of around 8 degrees. Due to the landing strip being much smaller and, well, moving, we require a few helping systems. First, we use a navigation map to fly into the landing approach to get the correct flight path. Then, a ball pops up on the HUD and tells us to either raise or lower our altitude to achieve the optimal glide slope. While we hold this ball in place, we need to start compensating for the aircraft carrier's movement and align ourselves to the runway and aim for a touchdown on the wires. Once we touch down, we give full throttle in case no wires are caught by our hook. If is called out, then we must immediately take off as our hook caught no wires. Only once we come to a complete stop do we throttle down. Carrier landings require lots of practice and patience, but once we master all the basics of flying, things too tend to get boring. Sometimes we need some action. So, let's get started on the weapon systems in VTOL VR. Weapons usually consist of a payload and some way of transporting the payload. The first and simplest type was invented in World War I, where they stuck an ordinary machine gun onto a plane. Today, we take this to the next level, by strapping the plane onto the gun. Guns are great for quick and dirty work against not so highly armored targets like other aircraft, vehicles, ground equipment, and people. Now, for highly armored targets like bunkers, we have dumb bombs, aka unguided bombs. They rely on the accuracy of the pilot to hit their target. Because these weapons have little to no technology and are therefore big hunks of explosives, they are cheap and they can be pretty big. But what if our current situation doesn't give us time to aim, or we need very high accuracy? Well, then we need some kind of guidance system. The simplest way is to slap some actuating fins into the bomb, and using its current GPS position and speed, it can guide itself to a GPS target. If we have multiple GPS points, we can drop many bombs in a matter of seconds that guide themselves to their targets. But what if the target is moving? That's what laser and optical guidance is for. The pilot can point a laser designator at a target, the bomb guides itself to wherever the laser is pointed. If the laser tracks the target, then so will the bomb. But what about planes as targets? We can't drop a bomb onto a target that's at the same or higher altitude than us. That's where missiles come in. They have propellant that burns to provide the missile with more energy to climb altitude and change direction rapidly. As our targets tend to have large heat or infrared signatures compared to the background, the missiles can use this to reliably guide themselves towards the target. This, coupled with their small size and ease of use, makes them great for close-range targets. Infrared missiles have one issue though. Due to the heat signatures dropping off rapidly, infrared missiles can't lock onto distant targets and they can be easily fooled by flares. So, what do we do about this? We need a way to more reliably track a faraway object. For this, we're going to take a look at microwave. No, not that kind of microwave, this kind of microwave. Microwaves can be produced electronically at precise energies, frequencies, and angles, and also get reflected off by objects, especially large flat ones. If we send a short microwave pulse at a specific angle and frequency, using the time it takes for the pulse to return, its direction, and the frequency shift due to the Doppler effect, we can detect an object's distance, bearing, and radial speed. We can use this information to guide our missiles, and if our missiles have their own close-range radars, they can become even more accurate and hard to evade. Radar is therefore much more capable of detecting objects more reliably and further than infrared missiles. We can even use radar emitters as a guidance source, allowing us to not even send out our own radar signals. This enables us to take out enemy ground radar systems without us ever needing to send our own signal. These are called anti-radar missiles and are great for stealth missions. Now, all these systems are great, but each has their own issue. So, in comes the most advanced type. We can use advanced computer algorithms to combine this information from multiple radar, optical, and GPS sensors to independently find, classify, and track targets, allowing us to not only fire the missile, switch to the next target while the missile continues tracking on its own, hence the name fire and forget, but even allows the missile to be fired from behind cover like mountains without us requiring a lock onto the target. These weapons are the most useful type, but of course the most costly. There are even more weapon types, and talking about them all would take too long, so here's a list of all the weapons in VTOL VR. So, in general, use GPS for multiple predefined stationary targets, laser for moving ground targets, fire and forget for more advanced stealth missions, anti-radar missiles for ground radar emitters during stealth missions, infrared for short-range air combat, radar for long-range air combat, oh yeah, and the gun for anything quick and dirty. So, this is all great, until these systems are used against you. What do we do about this? This is the F-45A. If you ask the designer what the radar cross-section of the F-45A is, they would ask you, what do you mean? The plane is similar to the F-35C. It has highly advanced systems and puts the VTOL in VTOL VR.
1, 0, liftoff. We have a liftoff. 32 minutes past the hour. Liftoff on Apollo 11.
All All F-45s are connected with a data link, allowing them to share information about an enemy target. All this makes the F-45A perfect for multi-role and stealth missions. Now, this is all cool, but as we asked, what do we do about enemy weapon systems? Well, first and foremost is not to be detected. We want to reduce radar cross-section and therefore also detection range. We can do this by mounting weapons inside the F-45A. We can also use mountains as cover, completely hiding us until we take our shot, or even use advanced fire and forget weapons from behind cover. But sometimes we have no other choice but to be detected, or there are unexpected enemy defenses, and we come face to face with the enemy weapon systems. To make any further decisions, we must know what we're even up against. For this, we must use one of the most important weapon systems that all aircraft have. And you've probably also been wondering,
Warte, hell ist Set Beeping.
the radar warning receiver and missile warning system. The RWR detects a radar signal's direction and also if the radar has a lock onto the aircraft. It's also able to discern between missile radars and ground radars. The MWS uses cameras along the aircraft to detect smoke trails and notifies the pilot if a missile has been launched. Together, these two systems can inform you about radar, radar direction, radar lock, missile launch, missile radar lock, aka pitbull, and missile distance and direction. Using all this information, we can make the correct evasive move according to the missile type and situation. In the case of a radar missile, we will get a radar detection and lock warning from the RWR before a missile launch warning. If you immediately get a missile launch warning without a lock, then it's most likely an infrared missile. For radar missiles, if possible, and the missile is not in pitbull, we try to break the line of sight from the radar by taking cover behind a mountain. If there is no cover and the missile is far away, by changing flight directions and gaining altitude, we can make the missile lose energy, or we can guide the missile to the ground or into a mountain. This is possible because the missile heads to where we're going to be and not where we are. If all this is not possible, we must use chaffs. Chaffs are clouds of highly radar reflective material that a radar can lock onto. But due to the Doppler effect, the radar can discern us from the chaffs. Therefore, we must fly at a 90-degree angle to the radar, reducing the radial velocity, and then drop chaffs in the hope that the radar locks onto the chaffs and not us. But this also only works if the missile is not gone into pitbull. This is called notching and is a fairly reliable tactic. The last method is to G-pull. The idea is to outmaneuver the missile by changing direction shortly before impact before the missile is able to compensate. We increase speed and place the missile to our side, and a few seconds before impact rip as many G's in a turn as possible.
Under the glottis, hold your air.
Now, what about infrared missiles? The issue with most of the tactics against radar missiles is infrared missiles are typically used at shorter ranges. This makes them smaller and lighter, meaning notching, G-pulling, and guiding into mountains or ground does not work. But there is one technique that is very reliable and easy to do. The same idea is using chaffs by fooling their guidance system. We drop hot and bright burning flares that the missile can lock onto. To make this even better, as we drop the flares, we throttle down, reducing our own heat signature. So, to summarize, for radar missiles, we can identify them by their lock before they launch. The first step we can do to fight against them is make the missile lose energy or guide the missile to the ground or mountain. If this is not possible, then we must attempt to notch by using chaffs to lose lock during turns at 90 degrees towards the radar. And the last thing we can do is a G-pull to dodge the missile. For infrared missiles, we get an immediate launch warning with no radar lock, and the only thing we can really do is to reduce throttle and drop flares. But this usually works. Alright, enough with the theory. Let's see all this in action. So, for this mission, I'll fast forward the boring parts, and on the top left I'll have the current thing happening with what's coming up below that. Further below that, I'll place some additional info if needed. On the right will be important notes and actions taken, like dropping flares and chaffs, and missile identification, and so on. In this two-part mission, we are tasked with clearing the island of enemy forces. The first is stealth, to take out any enemy air defenses like aircraft and ground-to-air SAM sites. After this is completed, we land at the support point on the other side of the island, and ready ourselves for the second part. In the second part, we must take out the rest of all the enemy equipment. So, enjoy!
Kilo 1-1, locked in. Throttle down and run your launch checklist. Kilo 1-1, shields up, ready to go. ground crew is ready to rearm on your command.
Shoot. Over T.
Welcome back. Follow the taxi path to your parking area.
I hope you enjoyed this video, and it was a great demonstration of general weapon system principles and how well VR simulators like VTOL VR are capable of replicating the real thing.